Hello, my dear friends. Welcome back to the next edition of continuation of exercise 9.4. So, last video, if you remember, we have done up to question number 6. Sorry. So, let's continue with question number 7. Separating the variables. So, that's y log y dx. So, let's try to separate. So, that's y log y dx equal to x dy, or 1 by x dx equal to 1 by y log y dy, or this time I'll try to write y on this side. That helps, I think, with the constant with respect to the textbook now. So what are we supposed to do now on after separating the variable? What shall we do on integrating both sides? Integral of 1 by y log y. Your integration, as I said before, has to be good, very good. So what we can do is, maybe you can use substitution. If you can do directly, no problem, or you can use substitution on one side. That is, if we take log y as t, then differentiating both sides, if you remember substitution, log y equal to dt. With respect to y. So that will be 1 by y dt upon dy, or 1 by y dy is equal to dt. So that means on this side we can have, this implies, you can write this after this, you can continue here. I'm just for space, I'm writing it here, okay? So 1 by log y is t, and 1 by y dy, that is 1 by y, this one 1 by y into dy, that is dt. Now substitution method, 1 by x dx. So what do I have here? I have here log of t, here I have log of x, so log. So the other constant, if you remember last video I told you, we'll take log c instead of constant c. So that will be log of t. What is t? That is log y, no? Is equal to log of x into c. So log can be by taking anti-log. We will have log y equal to x into c, or y equal to e power cx. Okay, so it's better to take y on this side. That helps many a times. Alright, question number 8. What do we have? X power 5 dy by dx equal to minus y power 5. Let's separate the variable. Dy by y power 5 is equal to dx by x power x power 5, negative value here, no? Dy by y power 5 dx by x power 5. Clear? So then integrating both sides, what shall we have? Y power minus 5 dy equal to minus x power minus 5 dx. Okay? Alright, write down. You can pause the video. Chalo, I'll move on. Okay. So that will be y power minus 5 plus 1 minus 5 plus 1 equal to x power minus 5 plus 1 minus 5 plus 1 plus c. I'll use that c here because no log here, no problem. So that's x power minus 4 by minus 4 equal to, sorry, minus is there, minus x power minus 4 by minus 4 plus c. So instead of just cancelling this, y power minus 4 by minus 4, this minus, I'll bring on this side, plus x power minus 4 by minus 4 equal to c, or y power minus 4 plus x power minus 4 common LCM by minus 4 equal to c. So that implies arranging and writing x power minus 4 plus y power minus 4 equal to cross multiplying minus 4 times of c. Or as per the textbook, we can have x power minus 4 plus y power minus 4 equal to a. Why a? And or what is a? A is minus 4c. And why a? A is a constant, minus 4c is also a constant. So does it matter? No. So can I keep it like this? No problem. Question number 9, that is dy by dx equal to sine inverse of x. So dy equal to sine inverse of x into dx. So integrating both sides, sine inverse of x into dx. Remember the integration by parts? If not, kindly check through the videos I have given you. So y equal to integration by parts, inverse comes first, algebraic comes second. So we can write sine inverse x into 1. So I, L-A-T-E, I was late, remember? So let's begin our integration. That is sine inverse of x into 1 with respect to x minus whole integral of derivative of sine inverse of x integral of 1 with respect to x whole integral. So whole integral. Yeah, of course you can write plus c also. So sine inverse of x into x minus derivative of sine inverse x is root over of 1 minus x square. This is x with respect to x. So y equal to x into sine inverse x minus integral of x by root over of 1 minus x square with respect to x plus c. So maybe here also again we can use substitution. Maybe let 1 minus x square equal to t. So that's minus differentiating both sides. Come on, minus 2x dx equal to dt. Right, integration as I said you already know. So x dx can be written as dt by minus 2. Okay, so let's go back to this substitution. So I'll put it here. Pause. Okay, chalo. So then y will be x sine inverse x minus x dx. What is x dx? dt by minus 2. So dt by minus 2. 1 x dx already written. So that's 1 by root over 1 minus x square. 1 minus x square is t. So that's like 1 by root over of t plus c. Okay, no? So that's going to be y equal to x sine inverse of x minus plus 1 by 2 integral of t power minus 1 by 2 dt plus c. 1 by 2 goes up, minus 1 by 2. So that's x sine inverse of x 1 by 2 t power minus 1 by 2 plus 1 minus 1 by 2 plus 1 plus c. X sine inverse x plus 1 by 2 t power 1 by 2 1 upon 2 plus c. I'm writing all the steps. You can reduce the steps if you wish. 2 by 1 root over of t plus c. So y equal to x sine inverse x 2 cancel root over of t. T was 1 minus x square plus c. Job done. That's y equal to x sine inverse x plus root over of 1 minus x square plus c. Oh yeah. Question number 10, that is e power x tan y dx plus 1 minus e power x sec square y dy equal to 0. Now first separate the terms, after that only we will be able to cross multiply and separate the variables, otherwise kind of difficult. Okay, xx on one side, e power x by 1 minus e power x dx, y on one side minus sec square y tan y dy, or sec square log x we can write okay, sec square y tan y dy equal to minus, I'll take on cross multiply this side, minus e power x by 1 minus e power x with respect to x. Okay, sec square y tan y dy equal to e power x by minus, if I multiply here, that's going to be e power x minus 1 with respect to x. I'm just trying to remove the negative sign. I think that's fine. Now minus, this minus I've just brought it here. That you can do, or maybe here itself while cross multiplying you can do that, no problem, that will be better. Okay, so minus multiply, that's going to be plus e power x minus 1. Okay, pause the video, write it down. Chalo chale. Now integrating both sides, sec square y tan y with respect to x, integral of e power x minus 1 with respect to x. So here also either you can do it directly, or I'll just show you the substitution method, that is let tan y equal to t. So in that case, they're differentiating both sides, we'll have dt. Okay, and here let e power x minus 1 equal to, let's say, u. So differentiating both sides, e power x with respect to x equal to du. Okay na? Chalo. So that will be sec square y dy, that's going to be d. What have I done? Okay, this is dy na? So that will be dt by tan y is t, that's equal to e power x dx, that's du, and this whole term is u. So that will be log of t equal to log of u. So you can see log, so the other one, what shall I take? Log of c. So that's going to be log of, what is the value of t? Tan y equal to log of, okay, let me just write together first, u into c. So that will be log of, what was the value of u here? E power x minus 1 into c. So okay, one more step, no problem. Tan y equal to log of e power x minus 1 into c. So log, by taking anti-log, we have tan of y equal to e power x minus 1 into c. Okay, so that's it up to question number 10. 11 onwards, we have a slightly different equation, particular solution. This was general solution, now particular solution. Particular solution, nothing much, just that we'll be able to get the value of c, so that we can have a particular solution, not a general solution. Okay, na? Alright then, I'll see you in the next video where we'll wrap up this exercise. Bye bye.